Okay, so this is a short introduction to Venn diagrams. Essentially, I'm going to give a bit of background to the problem I was sent. Okay, so I'm going to assume that you know about sets and how to manipulate them. So before we get to the example, we can consider two sets. Set X has elements A, B, C, D, and E. That's this one here. Set Y has elements D, E, F, and G. Okay, so this is mathematics. It's a bit abstract. In the kind of worked example, it's a bit more practical. So once you have sets, you can kind of manipulate them together. You can ask questions like X union Y, and that's the collection of all the elements in X and all the elements in Y. And in that case, you have in X you have A, B, C, D, E, A, B, C, D, E, and Y has D, E, F, G. So the number of elements is A, B, C, D, E, F, G in the union of X union Y. And the way the sets work, you only include one element just once. You can also ask other interesting questions like, what is the intersection? X intersection Y, this is here. And that's the number of elements that are both in X and Y. And in this case, you can see that X has D and E, and Y has D and E, and they have no other common elements. So the intersection X intersection Y is the set D, comma E. Okay, so you can use all this kind of formalism to do little calculations, and I'd say a Venn diagram is really just a picture of the sets and the relationships between them. It's just a kind of way to visualize all the mathematics to make it more transparent. So the way that you draw a kind of a circle for one of the sets, call it X, and in this part of the set where the circle's on its own, you just put in the elements of the set X, which are just in X, in this case A, B, C. And then you do the same thing for the set Y. Here you have a circle. And then in the bits on the circle on its own, you put F and G, which are the elements of Y that are just in Y. And then in the common area, you put D and E, which is the intersection. And then you can use the little diagram to represent these numbers. So if you want to do the union of X and Y, you just report all the elements in the two circles. If you want to look at the intersection, you look at the intersection of the two circles, which is just D and E. And I'll just explain this other thing, this universe thing as well. That's usually U stands for universe, and that's the set of all elements in the universe. Because sometimes you'll have elements that say are not in X or Y, and those go outside the two circles. They're not classified into any sets, but they're sort of in the universe. Okay, if you want to make things, well, see from the applications, want things more abstract, you can just, instead of just reporting what the elements are, you can just count the number of elements. So in this case, because number of elements just in X is A, B, C, you can just put 3 there. The intersection, which is D and E, the intersection between X and Y, that's 2 because there's 2 elements, you just put a 2 there. And the F and G are just in Y, that's the circle here. And then you just put 2 elements. And it's just a way of counting. And we'll see, when I took a little bit about applications, actually counting the number of elements in different sets and different intersections, and it's actually one of the important applications of this thing. Okay, but at the moment this is just definition, this is just kind of pure maths. Okay, so let's go down to the worked example. And so once you know what the so this Venn diagram is just a way to visualize all the different sets and the relationships between them. That's kind of the key point. So here you have the set of golf. You have this is from some questionnaire. You have the people who play golf, and there's 12, and this 12 means there are 12 people who just play golf. They don't play any other sports. And then there's 5 here because the intersection between the golf and the tennis bubbles. You have 5 people who just play golf and tennis. And then here we have this 22 number, just counts the number of people who don't play any sports at all. Okay, so in this diagram, here's the universe again, represents the sets, and then really the question then they start to answer, can you convert that understanding what the sets means into relationships? Can you convert this diagram into questions like what is the union of the sets, or what is the intersection? Okay, so the first question is how many people play golf? So you have 12 people who just play golf and no other sports. You have 5 people who play golf and tennis, 4 people who play all 3 sports, and then 7 people who play football and tennis, football and golf. Sorry. So you just add in those numbers to tell you all the people who just play golf. If you want to know the number of people who play golf and tennis, so that's here. So you want the intersection of the golf and tennis, and here you have 5 people who play 2 sports, golf and tennis, and then you have 4 people who play 3 sports, including golf and tennis, and then you have to add those together to give you 9. Okay, so this is one of these things you have to be very careful about how precise the question is, because you have to think very carefully that golf and tennis, does that include the people who also play football? And my interpretation of this question is it does. Then you have to play the number of people who play all 3 games, and that means so remember in this little circle, this counts the number of people who are in different sets. So you want the intersection of the number of people who play all 3 sports, and that's the intersection of all 3 circles, which is here, the 4. So that's the number of people who play golf, tennis, and football. So that goes 4. And then there's this football only. The keyword is only. So my interpretation of this is, so this is just people who play just football. They don't play tennis, and they don't play golf. So that's just the 10 here. That's what the 10 is. They play football only. So this is just this part of the circle. And then again, we're asked the question, people who play both football and tennis, and okay, so that's the intersection of the football and tennis circles. So you have 14 people who just play football and tennis and no other sport, and then you have 4 people who play both tennis, football, and golf. So the answer is 14 plus 4. Okay, and then if you also want to ask a question, you can make it more specific. Okay, I think I missed one of these things out. So if you want to ask this question here, none of these games, and so I told you that here's the little universe, and then you have here this 22 means people who don't play any sports. They're sort of people, that's why they're in the universe, but then they just don't play any of these, they're not in any of these sets, they don't play any sports. That's 22. So that's there, none of these games is 22. Okay, sorry about that, I got the ordering wrong. And then you can ask more specific questions, both tennis and football, but not golf. So that means you need to look at tennis and football. So that's going to be the intersection of these 2 circles, the tennis circle and the football circle. And it tells you what number of people who play tennis and the number of people who play football, but not golf. So that just means the 14. Because you say not golf, and 4 people play golf, tennis, and football. So I mean, this is what this Venn diagram is. It's just a kind of device for visualizing the relationship between sets, and then you can kind of read off the different intersections. Okay, and then the final question is, what are the total number of people surveyed? And essentially just add up all the numbers in the Venn diagram, because you have 12 people who just play golf, 5 people who just play golf plus tennis, and then 4 people who play all 3 sports. That's 4, and we add in the 7, the 14, okay, the 26, and the 10, and then 22. So essentially just add up all the numbers in the thing. Okay, so this is kind of abstract. Why would you want to do this? Well, when you do things like probability, some of this counting matters. So if you want to know what the probability is, if you knock on somebody's house, what is the probability that a person plays golf, tennis, and football? you can kind of use this diagram and these numbers to kind of compute all that. I'm not going to tell you how, it's probably a bit too soon to do that. And the reason why people want to do this, if you're a company who's trying to sell tickets to golf, tennis or football games, you can kind of use this kind of information that you get from, say, from a questionnaire or market research to kind of target your advertising campaign. And the way to visualize the numbers, so if you have some information of in a certain town how many people play golf, tennis or football, you can kind of target your advertising campaign a lot better. And the way to sort of understand, to visualize some of the numbers, is these Venn diagrams. And if you're interested in politics as well, if this application was instead of golf, tennis, football, this is what political parties people voted for or were interested in voting for. They're also increasingly in politics. People are using these kind of probability data analytics techniques to kind of coordinate political campaigns. Okay, so I hope that's been helpful. Okay, so that's just a short introduction to this worked example of this Venn diagram, which is just a picture of the sets and the relationship between them.